In this movie, we're going to talk about how to set up and route to run auto toolpath files. And as we said in our previous movie, our parametric design software is going to be used to generate a bunch of Dxf files where a separate part is in each Dxf file, and a cut list which tells us a little bit of information about each of the parts. So let's come here and take a look at one of these parts. We're just going to open up a default plate size, and we'll import a Dxf file. And this is one of the Dxf files from the job we ran in the overview. As you can see, this one Dxf file was a whole complete part, and there are different layers here. We have a layer that determines the cutout, and then we have some drill layers for drill hinges, drill drawers, drill pilot, drill shelves. These may or may not be going to the same depth, except in the case of drill pilot, it's always going to be going through, so definitely not this one. And then we have route and route back. And these are just internal cuts that are going to help the pieces fit together. So we have a different layer for each type of operation or toolpath we need to apply. And we can look at one more thing here. If I come to the top view and look at this from the side, I can see that the geometry is not at a 0 position. We are having a ability to read the cut depth for any given toolpath off of the position in the z-axis of the geometry. So all of these will be cut to a depth of 0.3760 regardless of what we set the depth to in the save strategy. This panel cut out is at minus 0.75, so that's how deep we're going to cut that one. And the drill hinges are 0.3937. Let's look at the drill pilots here. They go all the way through. So we're able to read the cut depth for each toolpath off the position in the z-axis. So what we need to do is come up with a few toolpaths here in our save strategies. And if we want to come here and take a quick look, we can see that boundary is the first layer name for panel, and this is going to get a routing offset, and we're going to need to save one of those, a routing offset. Drill hinges, drill drawers, drill pilot, and drill shelves are all going to be done with a 5mm drill. So I need to save a strategy that uses a 5mm drill. And route back and route are both going to use an island fill to cut out the inside of these areas. Some people might use a female offset as well, but an island fill can cover this area no matter how wide it gets, whereas a female offset will only travel around the inside perimeter. So I prefer to use an island fill here. So we need to create 3 strategies. All right, we're going to come here and delete this. All right, and actually we can leave this on screen and just use this to help us here. Now these island fills, what we're going to do is select these and go to the island fill strategy. We'll choose a tool of a 1/4 inch end mill here, and we'll specify a depth of 0.25. But as I just explained, we're not going to read this depth. We're going to use the geometry to determine how deep this should cut. So we'll put our feed rate in here of maybe 200. Oh, if we're going to use a 3/8 inch end mill, actually. 1/4 inch is kind of small for some thicker material, so we'll use a 3/8 inch compression, and that way we can go a little bit faster. And maybe we'll do 600 here. All right, so we've got our feed rate in here, and I just like to use a simple term here. I know rabbits and dado are different things, but I'll just call this a dado. And all these parameters are saved. Oh, that's why I'm using that tool. Excuse me here. We're going to change this back to a 1/4 inch end mill. And sometimes a down cut is used to give smooth edges. We'll do a feed rate here of 250. All right, that looks a little bit better. Now we're going to hit save as. Again, we're going to say dado, and yes, that's going to be our toolpath. And if we come in here, we can see it's just traveling around the inside of the part. But as I said, the nice thing about a dado is even if your part gets wider, you can still get full coverage, or about the island fill for cutting these types of shapes. Okay, so there's one of our 3 toolpaths. The next is this border cut, and here we're going to use the routing offset. So I'm going to come here and Choose a 3/8" end mill. Compression. We'll just give a sample depth of 0.76, and this one will bump up the feed rate a little bit. And I'm also going to put a 3D entry exit here. I mean, you can really put any kind of parameters you want to this, including which type of direction you want to go. Here I'm going to use a line entry, 2 inches long, 0-degree angle, and that just means it's going to follow in right along the toolpath and not come in from a slight distance. All right, we're going to save this one as cut out 3/8. We'll save this. Now I'll come back here one more time, and this time I'm going to add a little onion skin here. And this way we're going to be able to save another cut out 3/8, and then I just put with onion skin. All right. Now the last type of toolpath we need to save here is a drill centers with a 5mm drill point tool. We'll just put a depth of 0.25 or whatever you want there. And I usually go a little bit slower with these tools. And we're going to save this one as 5mm drill. Okay, now we have all the types of toolpaths we want. And if you're using open contours for doing rabbets, then you can come here and create an object that's an open contour, and then create an open contour offset to the right, left, or middle, and use that as well. And any type of toolpath that you need to use is what you create a save strategy for. All right, so now we're ready to begin the process of setting everything up. We're going to use KCDW as a pretty simple format to go with, but we do have a number of products here that we're compatible with. Cabinet Solutions, KCDW Pattern Systems, which is 2020, Router CAD, and a few others as well. So we're going to start with KCDW, and we're going to import a file. Okay, now this is a particular job, 7 parts, and this is the job of the part we were looking at just a minute ago. And the first time you have to set this up, but then it's always saved, so you don't have to constantly redo it. We're going to say use KCDW, and this shows us all the layer names of the part, or the jobs that we the files that we brought up here. So this is all our layer names, and we're going to come here and we're going to assign to the panel layer a cutout, and for a small part a cutout with an onion skin. The drill hinge is going to get a drill centers. Drill drawer is going to get drill centers. Drill pilot will get drill centers, and drill shelf. So no matter what the variation of the depths are, we're using one strategy here. They can read the depths off the contours. Route back will get a dado. The island fill. The route will get the island fill, and the route tab will get an island fill. So those are all our layer names. Now here, the only place I'm going to use design depth is with this cutout. When I save my strategy, I saved it at 0.76, but my material design depth was 0.75. Now, and Routes can remember the difference between the save strategy and this design depth and apply it to all the layers that get the routing offset that are in the lane panel. So that's a way we can add a little extra depth to a toolpath. The next step here is use depth, which means we are going to read the depth off the Dxf files. Toolpath means, or TP means toolpath. NT means nest together. If all of my parts were in one Dxf file and each part that I wanted to stay together was grouped, I can nest these separately and process just a single Dxf file. But since each part is in a separate Dxf file here, we're going to choose nest together. And finally, I have output, which means it's outputting the file to en route, or that particular layer. The next thing we're going to set up in our definition here for auto toolpath, now that we've identified all of our layers and assigned a strategy, is to go to the ordering and nesting tab. Here I have strategy at the top of my priority order. So I'm going to go to the strategy order and make sure that the output does a drill first, then the island fill, then the offset mail. Now we're going to come here and see the other priority. The next priority is tool. And I also have this set up at, I might move my mail offset tool down a little bit lower. Then the next thing we're going to take a look at is the nesting options. And because I have all of my parts oriented in a long x-axis, I'm just going to rotate 180. And I'm not going to have any gap or margin there. There's a tiny gap that's built into the nester because there's a small tolerance. So I'm just going to use that and let these get as close together as possible. I can use a negative plate margin here if I want to move backwards in the material. To allow my toolpath to go a little bit off the material, but still keeping the part in the material. So there is an option for a negative plate margin if you have a real short, tight parts to fit on the screen. Next, we're going to choose our default plate size and the top of plate or bottom of plate for the toolpath. The final thing we're going to do here is decide what's going to be output when we process these KCDW files. So the things we have to decide here are we going to create output files, which in this case we are, as a default setting. Do we want to create a printout of the parts? Yes, we do. If you have the label option, there's label output. And process as single parts is something you would do if you were going to set each part after it's cut out on a fixture and then process each part individually, something commonly done with point-to-point machines. So we're not going to do that here. Now we'll determine the output file name. So we're going to go to just put it in the auto toolpath folder, and we'll call this 123. Now what we're going to do is come here and save this as our KCDW new, and I always just name this something that relates to the type of program I'm going to be running with. So we're going to save this as KCDW new. Now anytime I bring in a file, I'll import my list file, then I'll load KCDW new, and I'll be able to maybe just change the name and process it. So since we're going to process some parts here, let's use Adobe PDF. All right, and we're going to hit this. We're going to hit process KCDW. Now there's just one output file here. So some of the things we need to decide here on this setup page are we going to create output files as a standard thing? Do we want to create printout of parts? If we have the label option, are we creating labels for all the parts that are processed? And we also, we probably change the output file name based upon every job. And I'm going to print this up to Adobe PDF here. All right, so once you have all your layers defined, you have all the ordering and nesting taken care of, along with the default plate size. And here I'd probably want to do small parts first. Maintain part grouping will, by unchecking this, it'll allow us to separate the parts and maybe sometimes make for a little bit faster output. And then we made sure we saved all this information. Now we're going to save this as, and I'm going to call this KCDW new. Okay, so now every time I want to run a job, I would first load the list file, then load KCDW new, and then hit process. All right, so let's go ahead and process these. Okay, it looks like there's 2 files here. All right, we're going to call this layer 1. layer 2. Alright, so here's layer 2, and we can see that. Okay, so we got layer 2 up here a little bit better to see. And here is the kind of layer printout you get. So we can see here's our parts, and it lists what each of these part numbers are. And we also have one for the back, which is what's on the other layer. So this movie shows the process of how to create strategies and how to identify which strategies you need to have, then create them, and then to go here to the Auto Toolpath button and import the file, come here and choose Use KCDW and assign each of these. The last step here would be to go to the Preferences, which F10 is an easy way to get there. Go to the Initialization tab and see that we have a threshold set up here for 100 square inches. So anything less than 100 square inches is going to be considered a small part. So here in this case, this part would be close. All right, and the last thing we can do here is to come here to our Solutions menu and start up Backplot. And Backplot is a little G-code previewer that we include as part of EnRoute, and it can be found in the EnRoute 4.1 folder. Okay, we've got Backplot here now, so we're going to open this file. And we're going to go to Auto Toolpath, and these are the two output files we created. So we can see this is what the output looks like. So this is, as I said, an overview of the process here, and we'll do a couple other movies to demonstrate a few other capabilities of EnRoute Auto Toolpath.